Raunik, get that. Look right there.
I'm trying.
Why is it not moving?
Oh my god, bro.
Oh, hell no, man. What the-
Okay, now we have 4 options on what we can build on our robot. I'll start with the square insert and bearing flat option. The build method is used by lots of teams in VEX. It uses bearing flats on both ends of a drive pod with an axle going through. On this axle, you can attach anything you need, such as gears or wheels. Remember to use a square insert in this design. The good thing about this design is that you can take a motor and attach it to this axle. All you need to do is remove the bearing flat here, and boom, you have a powered axle. This design is very easy to build and does not need any special materials. However, the friction on this design is not great and axles are easy to bend.
To solve this friction problem, you can use this design instead. This design is much better than the last one for friction. It uses these square bearings and these round inserts to allow for the wheel to spin. The friction on this design is much better. The materials for it are still easy to find as well. However, it can be hard to align these shaft locks properly with the C-channel and can be challenging to build with systems of gears where the spacing matters. Additionally, these axles still can bend like the ones in the last design quite easily.
This is why we can use screw joints in our drivetrain. A screw joint uses a screw instead of an axle, which the wheel or gear stays on. One of the screw joints we can use is this one. This design uses a long screw going through the C-channel. A nylock is on the other end to keep it in place, but is not tightened too much because it can bend the C-channel. A cap nut is also placed right here and is used to keep the screw tight and parallel while making sure the wheel is not too tight. This design has some great friction, as you can see here. These screws are also very strong and won't bend. However, these long screws needed for this design are not easy to find all the time. This design is also hard to build for newer teams, and they need to be careful not to bend their drivetrain when tightening the nylocks. Finally, this design can only work for a 3-hole gap between both sides of the drivetrain pod. Otherwise, the screw you use won't be long enough. This means you cannot fit some types of wheels or gears, such as mechanism wheels or high-strength gear. This is still pretty helpful in saving space though.
Sometimes, though, you need a bigger gap for the wheels and gears you use. For that, we can use this final design instead. This design uses a standoff right here and 2 screws to form a screw joint. This design lets us be more flexible with our spacing, as it isn't restricted by the length of the screw as much. The pep nut is still used to ensure the wheel isn't on too tight, and the design can be made as small as a 4-hole gap. Overall, this design is just as great as the other for friction. However, it can take up space, which for some scenarios is not great, and Shabaz's design may work better there. This design can also be hard to build. Those who make it need to be careful not to tighten the screw too much, as it can bend the C-channel. Also, this standoff needs to be tightened really well, otherwise it can loosen and ruin your overall drive friction in a match. With these designs, we can finally build a proper, functioning robot.